Hi, chemistry students. I want to do a Unit 6 review with you guys. I'm going to go through water cycle, carbon cycle, and all of that with you. As I'm going through this, what I want you guys to be kind of listening for and all of that is what is happening in each of the cycles. The better knowledge you have of all of these cycles, the better that you guys are going to do on this test. So I'm going to start off super simple with the water cycle, everything, something that everybody has seen before. I hope. So I'm going to start here and then kind of progress on down. Okay, so again, since it's the cycle, I can start anywhere. It doesn't matter where you start explaining as long as you explain the whole thing, right? So the first thing is precipitation. So precipitation is rain, snow, sleet, and hail. All of those things in which water hits the ground, all of those things count as precipitation, right? So the water goes ahead and it hits the ground. There are a couple of things that can happen when water hits the ground. If it's in a plant, right, what happens is that some of the water goes out of plants. So plants remove water, right, as they go ahead and as they go through cellular respiration. And when these plants remove water, some of this water goes back into the atmosphere, and that is transpiration, right? So that is this process right here. Some of the water that goes ahead and hits the ground during rain, it goes ahead and it seeps in. Oopsie. So it seeps into the dirt, and what will happen is that it goes down into groundwater. So that is what happens in percolation. So percolation is just kind of like the ground sucking in the water, basically. Okay. The next thing is evaporation. So bodies of water, the surface, if it's hot enough, right, the water goes ahead and goes from liquid to gas. So evaporation is just liquid to gas, right? And when the water goes into from liquid to gas, and again, it can evaporate from anywhere. Any puddle of water goes ahead and evaporates, right? So that is your evaporation portion, right? And then what happens is that the water is collected in clouds. And you guys all know this, right? But as you guys go up and further into the atmosphere is colder. And since it is colder, right, the water in the cloud condenses, right? So gas goes, oopsies. So gas goes back into liquid. And that is the big thing on there, is that the condensation causes the gas to go back down into liquid. And when it goes back down into liquid, eventually, right, the cloud gets super duper heavy, and we head back into the rain, snow, sleet, and hail. And again, right, if you are our water molecule, you can get stuck in different portions. So imagine all the water molecules that are in the ocean, right? Some of those guys might not circulate around too often. Some of them can stay in the ground. Some of them stay kind of like at the surface water and all of that. Some of it gets stuck as groundwater. But pretty much the water cycle, it's always moving. It might move faster in some places than others, but it is one of those things that is always moving. Okay, so next one. Okay, so the next one is going to be your carbon cycle, and we talk about how carbon moves throughout the earth and the reservoirs and all of this. I'm going to zoom in on this picture, and I'm going to spend some time talking about this picture with you guys. And again, there's a couple of different directions that I can go. But this is pretty much how water and carbon is moving out throughout the atmosphere. One of the big questions that I'm getting from people is, what is a reservoir, right? And all of those little R's, which are reservoirs, it's basically just a piece of storage or a place where carbon can stop, right? So this is kind of like a carbon stop, right? If the carbon can stop in a certain spot, right, that is going to function as a reservoir. Okay, I am going to go ahead and kind of start with some of my. I want to start with the bird actually. So I'm going to start down here. I'm going to start with this bird, right? And in this bird deal right here that I have, we have this bird, and how this bird participates in the carbon cycle is in only one way. This bird actually goes through respiration. So like it says on here, what we do is that we use the glucose, we use oxygen, and what we do is that we make carbon dioxide, ATP, and water, and then that carbon dioxide is actually released into the atmosphere, right? So it's basically that same thing. And the big thing about the carbon cycle, and like what some of the things that you guys should see, is that in the carbon cycle, when we are looking at these chemical formulas, what you will see is that these things are basically just going from one form of carbon to another form of carbon. So respiration is pretty simple. We have C6H12 O6 plus oxygen, and then that makes CO2 plus ATP plus H2O. And the big thing about these equations is that your carbon is going ahead and changing from one type of molecule to another type of molecule. So in this case, we start off with this glucose right here, and it ends up as CO2. And your equation, it does have to be balanced. So this one, I think it balances 6, 12, 6, 12 or something like that. This is 6. My bad. So those are going to be like some of the things that you guys are going to see on there. And you guys need to make sure that you recognize how carbon is going ahead and how carbon is like moving through the cycle. So that is pretty much like the biggest deal, is that carbon is moving throughout, right? So this bird, one of the other things that you guys have to recognize, is also a carbon store, right? And what I mean by that is that in that bird, right, there are some carbon that is like stored there that is required for the animal to live. So since that glucose is being broken down for energy, that glucose is also needed like throughout the body, and it's used to like build like all of the different things that we have in our body, because carbon is a very like, you guys already know that it can bond to many things, and so since that carbon can bond to many things, it's also in charge of making a lot of the molecules or the more complex molecules that we have in our body. Okay, so as we're moving through this, right, some of the stuff that is exhaled from this bird goes to the tree, and some of it that is exhaled by the bird also goes into the atmosphere. I'm going to start off with the tree, and then we'll move into the atmosphere. Okay. So there are a couple of things that kind of happen on here. First of all, you have to realize that trees absorb CO2, and that is going to be the big thing that happens in photosynthesis. So in photosynthesis, right, you take in carbon dioxide, you take in water, and you use the sun, and you use that to make glucose and oxygen. And if you guys are kind of reflecting back on the use of the molecules that are in cellular respiration and the use of molecules that are in photosynthesis, what you guys will see is that they're pretty much almost the same equation but backwards. And plants, the big thing to keep in mind is that plants actually do both things, right? Plants are another big store of carbon that we have. So you guys have to make sure that you guys understand that plants also store carbon. Again, they do use carbon to make many of the different molecules that are in their body. Okay, so those are a couple of things to make sure that you guys know. Okay, the next big thing is the atmosphere, right? Your atmosphere, so it's pretty much all of the air and stuff. The air that we breathe in our atmosphere does have a little bit of carbon in it, right? The carbon is actually needed on Earth because it keeps the Earth warm. If we had no carbon, if we try to win like carbon dioxide free, that wouldn't go well, right? Because we would eventually like freeze to death, right? So the atmosphere is super duper important. It functions as a carbon store. It helps store it, and it also keeps us warm, right? So we need that stuff, right? The next thing that you guys have is down here, which is decomposition. So decomposition basically happens anytime an organism dies. So you guys will see right there that there's like a little skeleton, right? So decomposition happens when we break down dead organisms, and when we break down dead organisms, basically all of the carbon that they had inside of them, because you have to remember that animals and plants are carbon stores, right? Those things get broken down, right? And they are going to go ahead and they're going to go back inside of the earth. So that is kind of like the thing that you guys have to keep in mind is that the carbon cycle is kind of like recycling that carbon. So once it dies, right, it goes ahead and it's stored back inside of the soil, right? And then you'll see right here that there is a little bit of a store of carbon dioxide in that soil represented by that R, right? It's in the soil, it's in the sedimentary rock. So carbon is stored inside of rocks, right? And then what can happen is a couple of things, right? Some of these rocks are very nitrogen rich. So in other words, not nitrogen, carbon. They're very carbon rich, right? And they are, when we burn them, we're able to produce energy. So we can find coal and fossil fuels down here very, very deep inside of the earth, which is why you guys really would have to dig in order to find coal or oil or any of that, right? All of those fossil fuels are animals that have been fossilized, so they happen to be like buried really quickly, and with the pressure and the heat and all of that, right? These animals and their remains basically turned into oils and stuff that we use. What humans have found is that if we dug up these oils, if we dug up the coal, it's a very good source of energy because of all the carbon bonds that are there, right? And you have to remember when we go ahead and when we break some of these bonds, some of the energy is also released, which is what we kind of take advantage of, right? And since we're burning all of this, right, we're releasing all of the carbon back into the atmosphere. Right. And that is kind of like one of the biggest things that we're doing, like human impact wise, is going ahead and kind of digging up those things and putting them out into the atmosphere. Another thing can happen is that the rocks that have carbon in it, which is a lot of rocks, can be going ahead and can be breaking down by water, right? So we have oceans, lakes, streams, all of that. You guys have seen pictures of how like the water like cuts through the rocks and it makes its path, right? When the water kind of goes ahead and it cuts through the rocks and it makes its path, right, it goes ahead and it breaks down, right, the CO2 that is inside of the rocks, right? So any carbon that's stored inside of the rocks, right, is eventually broken down. So that is called this whole weathering and erosion. You guys have totally seen this before in like waves and all of that. Those are all things that have been broken down, right? And then last but not least, we have diffusion, right? So diffusion is another process that we have in the carbon cycle, and it's basically just the spreading of molecules. So for example, if you sprayed like perfume or something in one corner of the room, eventually that smell will spread throughout the room. And when that smell spreads, right, that is the whole process of diffusion, right? So it's basically the theory that molecules go ahead and they move, right? And they'll eventually go ahead and that they'll spread out. So since these molecules are spreading out, carbon dioxide does the same thing, right? So some of the carbon dioxide is going to go ahead and you can have some carbon that is sitting at the top of the ocean, and you also have carbon that's sitting in the air. So what will happen is that some of them will come inside of the ocean, some of them will kind of pop out of the ocean, right? And that is one of the reasons like why the ocean is probably the one of the highest CO2 storages, because it has some of the diffusion going on, so it's absorbing some of the different things from the atmosphere. But you guys also have to think about that there is a whole other like marine ecosystem that is happening down here in the ocean. So there are like ocean animals and plants, right? There are ocean creatures, right? And those ocean animals and plants, they go through photosynthesis, they go through respiration, right? The ocean animals and plants also go through um, decay and decomposition. So you have a lot that's happening in the ocean. You have photosynthesis, you have respiration, and you guys have your own deal of decay, right? Also, it's absorbing some of the stuff that's getting weathered and eroded, right? So there's a lot of stuff happening near the bodies of water, which is why this ocean can function as a very high store of carbon. So that is kind of one of the things to kind of keep in mind, is that bodies of water are actually able to hold a lot of this carbon. So that is one of your biggest points. If you guys forget about this thing or don't quite understand how this diffusion thing works, another thing that you guys can think about is soda. Soda is pretty much what humans do, is that we put carbon dioxide inside of the drink, right? So that's kind of like the same thing. We're taking advantage of that diffusion and we're trying to put in as much carbon dioxide as possible. Okay, so those are your things on there. My next thing that I want to go through is I want to go through the spheres. I know the spheres are really basic, but I do have some people that are a little confused about the spheres and what the spheres consist of. So I want to make sure that everybody is clear on that, and I'm just gonna briefly like highlight what the spheres are. So pretty much your first one is going to be your biosphere, and that's any living organisms. Biosphere is all plants and all animals pretty much. You can even include bacteria and all of that stuff in there, right? So all plants and animals are part of that biosphere. Your geosphere, super simple. Your geosphere is your rocks. So any rocks that are included, right, is part of the geosphere. Rocks, landforms, mountains, right? All of that stuff is part of that geosphere. right? Next one is your atmosphere. That is pretty much the air above us is all part of the atmosphere. And then hydrosphere, this is just bodies of water. And your bodies of water are like oceans, streams, lakes, all of that stuff. And really remember that with your bodies of water, they have a whole different like ecosystem that's happening underneath them. So don't forget that. Bodies of water kind of have all of these things that are happening with them. Okay. I already talked about some of the impacts of the humans have, but I'll just review that real quickly. So to go through some of these questions, the different reservoirs is pretty much the ocean, the atmosphere, the geosphere, the rocks, the soil, living things. All of those things are carbon stores. Carbon is changed in each step. So ideally during this section, you guys would be going through each of the equations. I'm not going to go through this because I know that there's a lot of different equations that you guys can go through, especially with that whole plants and the carbon cycle and all of that. What I want you guys to do is to really look back at those equations. And when you guys are looking at those equations, like really like understand what is happening on there, and make sure that you guys know that carbon is changed from like one form to another. So you guys will see that there's carbon on both sides of the equation, and that's really the big thing that I want you guys to make sure that you're paying attention to. Um, the interactions is actually one of the things that people are having a lot of trouble with. I was really specific about water like eroding like the earth, which is how it impacts the carbon cycle. So that's like the main thing about the carbon cycle. That was a complete typo. That's carbon cycle. But that is what you guys are looking at, is that the carbon is moving from one thing to another, and there's a process in which that carbon moves, and then you guys will see those processes in the balanced equation. And since you guys have already been taking chemistry, right, you guys should know that that carbon is just moving from one type of molecule to another type of molecule. Both of them still contain carbon, they're just kind of moving around. Okay. Human impact. Human impact can be a couple of ways. Number one, we burn fossil fuels, and we put so much, and we pile this thing on, and the atmosphere can only hold so much, right? So the atmosphere is going to eventually be forced to go ahead and to put some more inside of the ocean, right? And this, in the other hand, changes like how acidic and stuff the ocean is, right? And then what happens on here is that we are going to go ahead and you can look at if we don't have enough of the atmosphere and we flood the atmosphere, right? We're gonna rely more on plants to go ahead and to take out that CO2. If we're also cutting down plants, right, then we have pretty much nothing to absorb the CO2, which is why plants and plant lives are super important, right? Super important to have trees and other plants to help us absorb carbon that is in our atmosphere. And good benefit from that is that it gives us some oxygen as well, right? So some of those are some of your impacts on here. And then I am going to cap this off with the nitrogen cycle. What I'm going to do is that I'm going to point out like the highlights of the nitrogen cycle. I'm going to go through the last few impacts, and then I'll give you guys some tips and tricks about the test. Okay. So, nitrogen cycle, there are a couple of main things that happen, right? We have the first thing that has to happen is nitrogen fixation, right? So what we have to do is that we quote unquote fix nitrogen. And the reason why we do this is nitrogen in the atmosphere, nitrogen gas, is not useful. It exists in the atmosphere. There's a lot of nitrogen in the atmosphere, but we can't really use it. So both plants and animals can't just suck nitrogen out of the atmosphere like they do carbon, right? So there's a couple of things that has to happen. Number one, you have to get it fixed by lightning. So lightning will go ahead and it will make some of that nitrogen into a nitrate. So that NO3 minus, and then you will also have some bacteria, right, that fix nitrogen. So they quote unquote fix nitrogen to that NO3. And again, what you guys will see in those chemical equations is that we start off with N2 and it ends with NO3, and basically that nitrogen is changing from one type of nitrogen molecule to another type of nitrogen molecule. So don't get tripped up by that. Just know, right, that the nitrogen molecule is just kind of like reconfiguring itself so that it is more useful. And that's ultimately like the goal of it, is that you want to make all of this like nitrogen that we have on Earth like more useful. So that's why we need lightning. That's why we need this bacteria to help the plants out, right? And then as that fixation goes ahead and happens, we are going to go ahead and we have a couple of other things that have to happen. Some of this nitrogen has to be like assimilated, or they go through ammonification. Oh shoot, I messed up. It goes through ammonification, right? And basically we go to that NH3 to NH4. And again, big thing is that it goes ahead and it changes, right? The nitrogen molecule is basically shuffled around, right? So that it is more useful, right? And again, we're trying to make these things as useful as possible, right? So it might go through that stuff. It'll mineralize. It'll basically go ahead and it will become more useful. Sometimes plants need like different types of nitrogen and all of that, right? In order for it to be absorbed, right? So all of this ammonification, nitrification, right? We're trying to make this nitrogen useful to plants, right? So we're trying to make it useful, and that's pretty much like the summification of pretty much the nitrogen cycle, is that we're trying to make this nitrogen that is in the air like useful. Once it is like useful and once it's kind of like in this like nitrate state, then the plants can go ahead and the plants can use it and take it in, right? And that taking it in is like this whole assimilation deal, is that it needs to go ahead and it needs to like take in, right, all of the nitrogen that's in it. So it might also be called mineralization and all of that. But basically what we want to do is that we want to make it as useful as possible, right? Nitrogen, super useful for plants. You guys will see that nitrogen is in DNA. Nitrogen is in protein, right? Nitrogen is pretty much in essential molecules. And the big thing that plants do for us is that they provide this nitrogen for the whole environment, right? So the only way that this little bunny can go ahead and can get the molecules it needs for its body is that it has to eat the plants that have, right, the nitrogen, and then that bunny can take the nitrogen, and with its body it can make it into its own DNA, its own proteins, and whatever else it needs to survive, right? And if there's like a wolf or something, right, the wolf or whatever is going to get those nutrients or that DNA that it kind of like picked up from the bunny. Whoops. Those nitrogen molecules, right, it will pick up the nitrogen from other animals. So another reason why this is important is that we are going ahead and we're kind of like passing down this nitrogen from one species to another, and we're passing it down this essential nutrients. And again, if you guys are having trouble with this, right, make sure that you guys go back and you like review all the slides and make sure that you understand how nitrogen is changing, right? And that it's a process. You guys absolutely don't have to like memorize it. I would just kind of know what's happening like at each step and how the nitrogen is changing and why it's important. And especially for the nitrogen cycle, you guys have to basically understand that we are just trying to fix the nitrogen, and we're trying to make, by fixing it, what we're trying to do is that we're trying to reconfigure it and we're trying to make it more useful. Okay? So now we talked about how great nitrogen is and it helps plants grow and all that good stuff, right? We have to also talk about a little bit about the human impact, right, of our nitrogen cycle, right? So nitrogens can be found throughout, and nitrogen's mainly found in soil because, as you guys can see up here, right, we have all of this like soil bacteria doing its thing, right? And we also have the creation of like fertilizers, and also when we do some factory stuff, we also put nitrogen out into the air, right? So factories add into the atmosphere, and fertilizers add into the soil or the geosphere, right? So we are able to go ahead and we're able to add these things, right? And the same thing, kind of like the carbon cycle, if we start adding stuff, right, we have to rely on other spheres or other processes to help us like take it out and to help us like balance what we are putting in and what we're putting out. In the respect of fertilizers, right, what you have is that you have these fertilizers that are being added, right? And since these fertilizers are being added, some of these are going to get washed away, and we can add, right? We can add N2 to the oceans, right? And that's kind of like one of the biggest human impacts is that when we add nitrogens to the ocean, we basically allow all plant life to go up. And while that might be a good thing, right, we can also kind of like choke out like other living things that are in there because now these plants have completely taken over, right? And some of these plants are not like regular plants. They don't produce oxygen that other animals need. And they might even like end up like covering this stuff, and there's like the whole eutrophication and all of that. And what happens is that it pretty much causes some of those animals to like die and stuff. So just make sure that you guys know that fertilizers and stuff, while they're good, while they make your plants grow, right? You can also have an excess of it, and all of the stuff that's supposed to stay in the geosphere escapes into the hydrosphere and the ocean, and it can impact like how much plant life is growing. Some of the fertilizers get so absorbed into the dirt that it also like leaches into the ocean. So very similar to runoff, instead of like just coming down the water, it's just kind of like diffused through. Humans also, when we burn things, we're inevitably like releasing more nitrogen. So since we're releasing more nitrogen, we're going to need more bacteria and stuff to help it even get inside of the plants. So that's kind of like the struggle with nitrogen, is that there's not like a lot of things to take it out, right? We're just pretty much relying on the bacteria that we have to go ahead and to fix it, or if we get lucky, the lightning to go ahead and to fix it, so that we can have a more useful form. But it's also super duper important because we need nitrogen to like build the basic molecules that are in our bodies. Okay. Last but not least, human impacts. Right, so human impacts for your cycles. The big thing to kind of keep in mind is that you see all of these cycles and they're all connected to one another. I know that some people might be confused about some of the connections and stuff, but you need to make sure that you understand that all of these cycles are connected, right? The water cycle kind of flows through both cycles. You see that water plays a big role in the carbon cycle, as water does help absorb carbon. Water also plays a role in the nitrogen cycle as well, because nitrogen also is floating in the ocean, and nitrogen can go ahead and can cycle through the ocean in pretty much the same way. This that happens on land, this also happens inside of the ocean. So that is kind of like how that thing interacts. But we also have the impact of nitrogen running off into the ecosystem, or just kind of transferring in through rocks if there's so much nitrogen that is inside of the dirt. Next thing, water in the carbon cycle, right? We talked about diffusion, and that's a big thing. Pretty much any human impact might impact all three. What you guys will see is that if I go ahead and if you're talking about burning like fossil fuels or something like that, for example, right, that's going to impact all three. So if I burn a fossil fuel, right, and I bring a fossil fuel that is from the geosphere and I burn it into the atmosphere, right, I can impact all three. Number one, right, I'm going to have more types of gases that are inside of my atmosphere. So I increase the gases. You have to remember that fossil fuels aren't just pure carbon. Fossil fuels also will have a little bit of nitrogen in them. Maybe not a lot, but it'll have some. And well, since we're burning like a good amount of them, right, all of that stuff is getting into the air. And since it's getting into the air, we're releasing more atmospheric nitrogen, right? So now we're going ahead and we're counting on all the bacteria that's inside of the earth to go ahead and to help us recover and help us fix, right, some of this nitrogen, right? And that's kind of like one of the big deals that we want to do, is that we want to fix some of the nitrogen that we have, right? So we're kind of forcing that bacteria to kind of work more, right? And we're also going ahead and we're adding to the atmospheric nitrogen. And if we're also burning some of these fossil fuels, we're also forcing, right, the ocean to go ahead and to absorb, right, some more carbon, some more nitrogen, right? And we're asking the oceans to absorb that. And we already talked about some of the impacts to the that ocean atmosphere, right? If you're absorbing more carbon, we're able to make the ocean more acidic, and we're going to talk about that in our next unit. If you are absorbing more nitrogen, again, what you guys will see is that the ocean has a high amount of nitrogen, and it kind of leads that whole ocean ecosystem to kind of go crazy. Some plants and other animals that go ahead and to use stuff very similar to plants might cause all of that eutrophication and all of that, right? And it's the same thing with like, if, per se, if you cut down like a bunch of trees, right, or there's a forest fire, right? In a forest fire, you're not only releasing a bunch of like carbon dioxide into the atmosphere, you also lose the ability to absorb carbon, You might also not have that many nitrogen fixing bacteria that's able to help you with it. You don't have all of those nitrogen molecules that's super important for plants and animals to help them grow are not going to exist anymore because you've essentially taken those things out of the food web. So those are all like impacts and all around, right? And if you have more forest fires and all of that, again, you can force oceans and stuff to kind of force them to absorb more nitrogen and more carbon dioxide than they're used to, which can impact like all of the creatures' health that live inside of the ocean or live inside of streams. So it's again kind of like putting those pieces together. So if I do one thing, right, and if I throw one thing out of whack, what is it going to do to all of the other systems? Right, and it's kind of similar to that map that we had you do. So those are some of the things to kind of keep in mind and some of the connections that you guys should make. Definitely, if you're having trouble, review the nitrogen cycle, review the carbon cycle. Make sure that you guys are seeing how things are changing from one type of molecule to another type of molecule, right? And make sure that you guys see that there are impacts as you go down the line. Right, so those are pretty much my tips and tricks. If you guys have any more questions, feel free to email me and stuff. Your test is free response. So make sure that you guys are all studied up and that you know what to kind of reply and that you're able to kind of apply what you've learned, because a big thing is to be able to like apply what you've learned. Okay, you guys have a nice day.